on how much does salary factor into performance in the MLB. So a little background is hold on. Yeah, so my inspiration to this project was the movie Moneyball. And so I also noticed, like, recently in the MLB, in the playoffs and stuff, teams with like lower salaries have been making a deeper run into the playoffs. And before that, I used to just think that teams needed a higher payroll in order to successfully compete in the MLB, because there's so many teams with higher salaries than all the other teams, and usually the higher salary players are the better players. So the package that I use is the data set that I found was from the R package for Lahman. And what Lahman is just a package with a database of all kinds of stats from 1850 to 2016. So to make things simpler for my project, I just used the years 2000 to 2016, since those are the more recent higher salary years. So data cleaning, I used R to clean my data because there were, so with the database, there was a bunch of data tables, but I needed to combine some tables so that I can get the player salaries combined with the stats. And and down here is just a picture of sample of my code that I use. There's a lot more to it, but okay. And so data visualization. So I was gonna do pitching for my entire thing, but then after using this data visualization for pitching, I noticed that there wasn't too much of a correlation between pitching and salary. With with ERA, it's actually going backwards. It's, yeah. And I mean, strikeouts, it's not that bad a correlation, but, and then you get like, I noticed that like with wins and strikeouts, it was actually pretty correlated. There's pretty good correlation. And ERA and batting average against. And yeah, the filters that I used for this was ERA no higher than 5. I only used the 2016 data because it's the most recent year on this data. And wins was at least 6, and salary was at least 3 million. And then the visualization for my salary, this is just the average salary across every year. And so the filters I used for this was at least 100 bats, because with this batter data, they actually put pitchers into the data too, because some pitchers from that play in the National League actually get bats too. So I did at least 100 at bats, because no pitcher in the league has 100 bats. And I use a salary of at least 300,000. So 2016 salary. So these are my models that I did on Python. And so the linear regression, I did a linear regression line for these. So the regression line for this was 0.000026 times salary plus 86.2698. And this was so I did it based off of 2016 for this one. And I just chose another year to base it, to take the line and just compare it to that year. So there's the regression line, and this one right here is just the hit error. So it's just the predictive values that are from this equation based on this year. And here I have the mean of the error. And since it's 2016, obviously the 2016 data hit errors around 0. So I noticed it seemed to, like, as the years got higher, it would get like closer in error. And I believe that's because the salary was higher, like, because the salary gets higher and higher every year. And so to try to like fight that, I used an adjusted value for my salary. And I noticed that still it kind of, I mean, it made it lower, but it still kind of is a little bit different. And yeah, next. So I did a bunch of different models here. So this is 2016 RBI model. And yeah, it's the same thing, pretty much, just RBIs. And yeah, these are pretty much all the same explanation that I already gave. Yeah, so with the conclusion of my data, I noticed that despite some models' means being lower, that it wasn't the correlation in salary stats, like compared to the stats that I chose to do it with, it just wasn't very correlated. And there wasn't, so like I noticed that salary wasn't too much of a factor in performance. Although there were factors that, like the pressure of the contract that the higher contract players got, could be too much pressure on them, which is making them perform worse. And then I just noticed that like the biggest correlation out of anything that I found from this was hits versus runs, and it had the R-squared value of 0.94. And in future work, I will be collecting data for players by position, just to see which positions have like a higher average salary, like based off like what teams should pay per position. And I'll also try to see what pitching data would look like a little bit more, and then work on the accuracies of my models a little bit. And any questions?
Any questions for Jimmy, please? So did you pursue simple linear regression or any other models as well?
So I only did the like simple linear regression for like a bunch of different stats. And yeah, these are like all different models like that I did on Python.
Did you happen,
what's up?
Did you happen to record the R-square coefficient and analyze it?
That part I didn't really do. I just took the mean. I just took the average means and based it off of that.
Thank you. Any other questions, please?
Yes. So did you find that teams that had a higher salary for their players, did they go further in the playoffs, or what was that your outcome variable, was how far did they go in the playoffs?
So pretty much like what I ended up doing was like based off of player performance throughout the years. But I did notice like going through it that it did seem like most teams, it was like a mixed result, basically. There was like half teams making it to the playoffs that were lower salary, and then like half teams making the playoffs that were higher salary. So yeah.
Okay, so it wasn't, you didn't find the salary, so it was about 50-50, you said?
Yeah.
Okay. That's just an interesting thing to think about.
Mm.
Thank you, Nathan. Any other questions, please? Anyone from our
Yeah.
panelists today?
Yeah, I have a quick question. Thanks for the talk, Jimmy. I guess my question is about building player-specific models. Sorry if you mentioned this in the talk somewhere, but yes, have you looked at or considered building models for just certain position players or National League,
yeah,
American League,
the
different kinds
future,
of? Sorry.
Yeah, in the future talk I was talking about, I'm gonna like create a model but for each position player, like for like, you know, left field, right field, catcher, based off position. I was gonna create models, but if I had more time.
Okay. Oh, great.
Thank you. Sorry.
Oh, as I say, just kind of a related question. Did you control for like players that either got injured throughout the season or switched leagues, or just kind of these corner cases that may reflect some of the large variances in some of the quantities you were trying to model?
That part I didn't really work into it. That's probably another thing I'd work into it if I had more time.
Okay, great. Thank you.
Yeah.
Any further questions, please? If not, let's thank Jimmy and